Hey YouTube, this is Bharat from ReadyReady's LLC. Today we are going to learn about the fundamentals of LVM, which is Logical Volume Management, and its various components such as physical volumes, volume groups, and logical volumes. First of all, let's dig into the details of what LVM is and how is it beneficial in comparison to the standard partitions of storage. Logical volume management is a disk management system used in Linux environments. It offers advanced features and flexibility in comparison to traditional partitioning methods. LVM is a logical layer that sits on top of physical storage devices, abstracting them into logical volumes that can be dynamically allocated, resized, or managed. So let's get started here. Currently, I'm on a VM, a virtual machine, and we have like two additional virtual disks attached to this VM for the purpose of this demonstration. So the first phase of creating a logical volume would be to have a volume group. So if you use this command, which is the VG display command, you'll know if there are any volume groups in your server or not. Currently, we don't have any. And to create a volume group, you need physical volumes. Now, physical volumes are the building blocks of a volume group. So let's start creating them. We'll be using the fdisk utility to create a partition from these additional disks that are attached to this VM. So I'm just going to create a new partition, which will be of type primary. I'll leave everything to the default, and I'm going to create the partition of the maximum size available. The same will be done for the second disk. Okay, and now when we do an lsblk, which is list block devices, you can see that VDB now has a new partition, which is VDB1, and the same goes for VDC1 as well. Okay, now that we have our partitions, we have to create physical volumes out of them. So just like VG display, we can run PV display to see if we have any existing physical volumes on the server, and obviously there's none. So let's start creating them. PV create dev VDB1. As you can see, physical volume dev VDB1 has been successfully created. Let's make another one for VDC. And now when I do a PV display, I'll get them, I'll get the output with the details of the physical volume, such as the UUID and the size of the PV. Rest of the details currently, we can skip that. I'll explain it in a later stage. So now, the next step would be to create a volume group. So VG create the name of the volume group, or I guess the devices first. So dev VDB1, dev VDC1, and the name of the volume group can be anything. So I'll just name it as a storage pool. Okay. I guess we'll have to name it first and then add the devices. Okay, so when I do a VG display now, as you can see, we have a new volume group named storage pool, and then we have a combined storage capacity of, let's say, 20 gigs. Okay, now PE size. This is something that is important when you're creating a volume group. You can also specify which PE size you want to maintain. Now, PE is nothing but physical extents. So what happens is it will chop your data up into 4 MB partitions and store them on the storage area. So the bigger the size, the more bigger the chunk where the data gets split. Okay, now that we have a volume group that is functional, let's dig into the details of creating, let's say, the logical volumes. Now, before we even get into the logical volumes part, let's understand what a logical volume is. A logical volume is a virtual storage entity created within a volume group using LVM. It's a flexible, resizable block of storage space that can be allocated to a file system or could be used for any other purposes, such as you can, provide it as an NFS or any other such thing. Obviously, it would need a file system on top of it. But yeah, the many other features that LVM also offers is dynamic resizing and scaling of these logical volumes. You can even take snapshots and backups. You can even configure RAID 0 and RAID 1, which is striping and mirroring between the two or more physical volumes that are present under a volume group. And the last feature, I guess, which would be quite interesting would be the thin provision. Okay, so let's move ahead with this. Let's create our first LVM, which would be LV create. I'll mention the size using the capital L, which would be 1G. Let's create a 1 gigabyte worth of LVM volume, and let's name it data. And where do we want to create it? We want to create it in the storage. Okay, so I guess we'll have to give the storage first. Okay, that's interesting. I'll give it a name, which is data, and just create it in storage. Okay, so now when I do a LV display, I get my first logical volume, which is called data, and it is present within the volume group named storage pool. So to get a better readable version out of it, I'll just say LVS, and now you can see that the LV's name is data. The volume group name is storage pool. The current attributes assigned to it are writable and accessible. The size of the LVM is 1G. Now, what if we want to increase the size of this LVM? What we can do is we can run LV Resize -L plus another 1G to dev storage pool data. And now, if you notice, the size of the volume in the storage pool area, which is for data, has changed from 1 GB to 2 GB. And now when I do an LBS, it will show me a 2 gigabyte worth of usable space. Now let's try something here. Let's make a file system on top of this LVM. So I'll create a ext4 file system on this. And that's done. And now I would like to mount it on the mount folder. And when I do a -H, if you notice, we have the LVM mounted here. So whatever data is present or will be written into this mount folder gets stored into this logical volume. Now, what if I want to resize it after I add some data? Now, I'll just go to the MNT folder. I'll touch something. Let's say example.txt. Okay, and I'll just put a high into that example.txt. Okay, and when I do a cat, it's high. And now I'll just move out of this folder. I'll unmount this. Oh, it's not letting me unmount because there is a process that is still running. So I'll just kill that process, kill 31993. And now when I do an unmount, it's unmounted. Now on df-h, it doesn't show up. Now I want to resize this. So LV Resize -L plus 2G. So I want to add 2 more gigs to this. And then I'll mention the logical volume. Now, it has changed from 2 gigabytes of size to 4 gigabytes of size. And when I remount it, dev storage pool data. Okay, now you see that it's still showing 2 gigs as max capacity, but when I do an LVS, it will show me that the size of this block of block storage, or the logical volume, is 4 gigabytes. Now what happened here? The size of the volume has definitely increased, but the file system hasn't expanded automatically. So what are we going to do about it? We'll be running resize to fs, which is the command for resizing the file system for ext4. And then I'll just say dev mapper storage pool data. And now when I do a df-hedge, if you notice, it is now 4 gigabytes of size. So an online resizing was done. It is required and it's done. So resize to fs makes sure that the resize is done regardless of its current status. Okay. So now we have learned about how to create a logical volume, how to create a file system on top of it, how to create a volume group, a physical volume, and also how to resize it. Now, please take a note that you should never downsize a logical volume or any partition for that matter on standard storage, because that will cause data loss, and it is never recommended to do that. So let's get into the next feature that LVM provides, which is creating of a snapshot. Now, snapshot is like a copy or an incremental copy of that logical volume that can be transferred to another server and converted into a block device, and the data will still be present to be used there. So let's create our first snapshot. So lv create, it's the same command, but we give a new argument, which is -s. Now -s specifies that a snapshot should be created, and then -n, the name of the snapshot. So I'll just name it my or data snapshot of the of, let's say, 03/04/2024, and then I'll just say I need the snapshot of this device, dev storage pool data. Oh, we also need to mention the size. So since it is currently 4 gigs, we'll just mention 4 gigs. Okay, so the snapshot is now created. And now if I do LVS, as you can see, it just created a snapshot over here that's currently present. Okay. Now what you can do with this snapshot, you can just create a snapshot folder just to test it out, and then you can just mount dev storage pool data snapshot onto mount or onto snapshot. Okay, now when I go into snapshot, I can still see the example text. So this way, instead of whenever you need to transfer data, you can just create a snapshot and you can just transfer that snapshot to another server as and when required. This also allows for minimal downtime and a flexible way of transferring data from one place to another without hindering the operations that are currently running. This is good. I mean, this has a good use case when you're dealing with databases or web servers or any such applications where the requests and the data is always on the fly. Now, obviously, since we are not having any RAID configured here between the two physical volumes, let's assume that they were actually physical disks. Now, if you need to configure RAID, usually you would do a software RAID. But since we are using LVM volumes, how do we deal or tackle the fact that we don't have any, RAID configured? So what we could do is we can use the a feature that LV Create provides, which is it allows you to stripe or mirror. For now, we go for mirror because that is our main concern. And So I've started this command with lv create, and I've mentioned that the type is mirror, and then -m means the copies of data. That means there will be only one copy of this, since it's just 2 disks. And then I'll specify the size of the LVM that I want to create. It would be 5G. Okay, and then I will name it. So it's data that is mirrored. Okay, and then I'll mention the the volume group. Okay, so what it's saying right now: insufficient, suitable, allocatable extents for logical volume. Okay, what we are going to do is we'll just create a 1G worth of logical volume here. So LVS. Now we have a mirrored version of this logical volume. If you notice, currently it is getting synced, and it was at 94%. Now when we do another LVS, if you notice, it is 100% synced. So whenever I create anything, I mean, let's just create a file system on top of this, dev storage pool, data mirror. Okay, and then I'll mount dev storage pool data mirrored on top of, let's say, oh, I just need to create a folder first, mirrored. Okay, and then I'll mount this. Okay, now when I do a df-h, I can still see mirrored over here. So I'll just get into that directory, touch mirrored.txt, echo hi. Okay, and now when I do an LVS, you see everything is still mirrored. So this is how you can protect your data in case you're using single physical volumes instead of performing a RAID, a hardware RAID or anything as such. So today we learned about the flexibility of how the storage can be scaled, and we also learned about how snapshots can be taken. We also learned about the RAID capability of LVM. So we'll go down to the last topic, which would be thin provisioning. Now, thin provisioning is a concept where you allocate a certain limit of data to a logical volume, but then unless and until that data is used, it's like it stays there. You're not wasting space unnecessarily. You'll create the logical volume, you'll let it consume the data up to the point where you've allocated to it, but it immediately doesn't, it immediately doesn't get rid of all the space that you have in your volume group. So for example, VGS is now having only 9 gigs worth of data free, right? When I created this mirror data volume, it consumed 2 gigabytes worth of data because since it's mirroring, it needs 1 gig on the first physical volume and 1 gig on the second. So we lost 2 gigs. Now, this is the reason when I mentioned 5 gigs, it didn't work, because the amount of data that we have to create a 10 gig mirroring was not present. So how do we create a new LVM with thin provisioning? Okay, so let's get into that. It's the same command. We use lv create. We mentioned that we need a thin pool, or we can just say that we need to create thin pool. We can give the thin pool a name. We can just say thin storage pool. Okay, the size of the pool can be like 5 gigs, and the volume group name would be dev storage pool. Now when I do an LVS, if you notice, we have a thin storage pool right now. So on top of a volume group, we are creating another pool of data, which is a thin storage pool. Now from this pool, we'll create the logical volume. So LV create, type would be thin, the name would be like thin data, okay, and the virtual size of this pool would be like, let's say 10G, and then you just give the name of the thin pool, so which would be thin storage pool. Okay, I think this should be thin storage. Ooh, no, it's thin data. Virtual size would be 10, 5G. This would be storage. Ooh. Yeah. So now when I do an LVS, if you notice, the size is still the same. I've created a 5 gigs worth of thin volume on top of a storage pool that has only 5 gigs limit. But if I create another, so right now it's giving you an error that the sum of all thin volume sizes exceeds the size of the thin pool. So you cannot create volumes above the max space. So it prevents you from doing that. But if you notice, you haven't used the 5 gigs allocated to you, and it still created this volume. So both these volumes have 5 gigs worth of max limit. Okay, so these are just warnings. So as soon as you start using them, they'll start expanding their storage. So I'll just I'll make a file system on both of them, ext4 dev storage pool, thin data volume, and then volume 2. Now I'll just say thin 2 on dev storage pool. Okay, so now if you notice, we have 2 mount points, each have the capacity for 5 gigs. Now if I go into one of these and create a dummy file, now what this command is going to do is it's going to create a dummy file of the size 1 GB. And now when I do a df-h, if you notice, the first volume has consumed 1 gig and is showing up as 22%. Now when I do an LVS, if you notice, the thin storage pool has used 24% of data. So that is like 1 gig out of 5 GB. And this specific thin volume doesn't have any data, but this one is using the rest. So that is how it works. So if you exhaust the 5 gigs of this pool, then this volume cannot store space. So it is like you're sharing the space amongst many other volumes, but when you reach the max space in either of the volume, then the pool is just exhausted and you cannot store any other files, even if your file system shows that that you still have free space available. So that is how thin provisioning works. Thank you for your presence here today on this channel. I know it's been a long time since I've released a tutorial, but we'll start resuming these in the coming weeks. I hope this tutorial helped you to understand the fundamentals of LVM. Any questions, do drop them in the comment section. Please like, share, and subscribe to this channel. And I hope today's tutorial helped you.